observability side of the gateway product here. Yeah, and I'll just walk you through the tracing and the metrics side of our gateway product. We'll first talk about general open telemetry tracing, how like the basics of it and how it works. Then we'll talk about how tracing works in context of the AI gateway product. We'll look at how you can add your own application metadata, how you can do filtering, fetching, all of these operations. We'll also look at how, if you want, you can export these traces to external systems. And we'll look at whatever new features we have added in last few weeks, right? Like mainly around how you can route data to different destinations, how you can configure advanced data access rules, how you can control what data should be logged and what should not be. And we'll also have like few extra features which are very new at the moment. Sure. So let's get started with the OTEL tracing part. So OTEL stands for Open Telemetry. To put it simply, it's a standard or spec which defines how you can instrument your application. So think of it like how you add log lines in your application to maybe see the progress of what is happening in a request, right? Now that log lines are a very, very basic mechanism to maybe gauge progress or log some info along the way. But what if you wanted like a complete overview of what is happening, like what function calls are happening, how much time each function call is taking, or each block of code is taking, how are they related? If there are things running in parallel, how much time each of them is taking, and when is everything completing, right? And if there are any errors, like how do I record those errors and details, right? So OpenTelemetry defines a specification on a very, very general and a basic level. Like this is what a span looks like, and this is what a trace looks like. So if we look at this screen over here, we see a tree like a structure. And what this means is this is a sample query from one of our internal services where I fired off some HTTP call. I got back 200 on it, and this is everything that happened inside that particular call. And here we can see there is like duration on each of these rows, and these rows are related to one another in a hierarchical fashion where some rows have some parents, some rows have multiple children in them. So this is what a general OTEL trace looks like. So this entire set of collection, this whole tree, is called one trace, and ideally that's meant to look at your one request or one transaction from an end-to-end basis. Now, inside a trace, there can be a trace is made up of spans. So each of this row is called a span, and each span has a bunch of properties, right? Like we can see there's a duration over here. We can see there are some properties which I'll talk about it. And yeah, each span can have like one parent and then any number of children inside it. And then there are some leaf spans where like there's no extra information after that point. And then there's a root span which sits at the very top. Uh, so each span in the hotel spec can have some compulsory properties like, okay, what is the span ID of this? And what is the overall trace ID? Like all of these spans will share a common trace ID, and each of these spans will have a unique span ID. Uh, Whichever span has a parent will also have a parent span ID so that you can do all of this tree linking together. You can add things like service name. This is meant for, let's say, what application the trace is coming from, right? Because you can imagine in a microservices system, there can be your single request can jump from multiple services. And you can in the hotel spec, you're allowed to trace across different microservices. So all of your spans will come under a huge tree, and then each of those spans can come from different microservices because your request has been jumping around. So there's a concept of service name. Then obviously each span can have some name. And then there are like some attributes that you can add to each span. Like in this particular case, like these are usually application defined. Or like for example, this trace came from a REST service. So in this case, it automatically added what was the thread name it was running on, or what was the what was the application logic that I was running here, which code file it came from. So you get to record all of this information in one particular place and in one trace so that you can get complete observability of what happened inside one particular request or transaction. Now, to basically create this data, you don't have to manually write every single span. There are convenient open telemetry client libraries in every major language. Most of the times, you can set those libraries to auto instrument mode, and they will try to record all the common stuff like your SQL queries or your HTTP requests, which are going out of your application. If you want, let's say, custom tracing where you want to make your own span, then these libraries also provide convenient functions where you can say something like start span and you can give it a name. And then everything that happens inside that particular block, it automatically will record that duration and a bunch of arguments if you want to. So yeah, so that's what a general OTEL trace looks like. Now we'll talk about it in terms of our AI gateway. So you'll notice like the AI gateway also uses almost exactly the same OTEL structure. In fact, the all the traces emitted by the by the AI gateway are OTEL compliant, and we basically extend the spec. So the OTEL spec uh, is 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 a generic spec which allows you to add any arbitrary span attributes or resource attributes, right? So that allows us to extend it and put our own properties inside it, which makes the AI gateway traces have some semantic meaning in context of, let's say, specific calls that you'd make to it, right? Like chat completions is one specific type, or image generation is one specific type. So you can imagine we can enrich each of these spans with some additional metadata, and that allows us to do advanced things where you can track maybe input output tokens, cost. You can add annotations for what got budget limited, rate limited, things like that. So it allows us to put semantic meanings to each span and each collection of traces. So the nice thing about Gateway is you don't have to do any of the tracing by yourself. AI Gateway will automatically emit trace for every request flowing through it. And from that trace, we can power obviously the request logs that you see, but also the metrics section. Yeah, so like if we take this one particular example, let's say we have this agent responses call. So the agent responses call allows you to connect a bunch of MCP servers, and it allows you to run a loop with those tools and the LLM model that you selected to achieve some particular goal. So in this case, I asked it a question something like, can you tell me the exact number of seconds till the next total solar eclipse, right? And I gave it tools like, I gave it the common tools MCP server, which TrueFoundry Gateway provides. Inside it, there's a web search tool and a code executor tool. So in this particular trace, it basically you can basically follow what happened throughout the call, right? It for the loop first figured out what tools are present, then it gave those tools to the OpenAI GPT 4o mini model. uh, there we get back some response where the model wants to call the web search tool to figure out, okay, when is the next total solar eclipse. Then it again connects to the MCP server, and it wants to now execute some particular code that it has written. Maybe because it has to look at the date and figure out what is today's date and do that subtraction to give me this answer. So you can exactly trace what happened throughout the whole call, how much time each took. If there was any exception, then what failed, and you get complete idea of the entire thing. You can also and because we enrich each span with some special metadata that makes sense in context of GenAI, you get to see this prettified view where this was a model call. So we can see, okay, what is the list of messages that exactly went in and what response did we get? What was the cost? What was the input output tokens? If there was any caching, latency, inter-token latency. So you get to view this in a prettified way, and obviously you have access to the entire thing in raw data mode. Uh, and since this is so closely tied to the gateway, we can also give you a try and playground button where this exact set of interaction can be loaded on the playground screen, and you can kind of reproduce it. I'll walk through all of this as a separate demo as well, just going through a few things before I move to the demo section. Uh, so the traces so far, whatever we've seen is emitted by the gateway itself, right? Like all of these attributes are automatically emitted by the gateway. But what if I wanted to add my own special metadata, which I can use for further bifurcation analysis or filtering, right? So the gateway allows you to send headers with every call that you make. This is a special header called XTFI metadata, where you can send your own metadata. Maybe I have a booking bot where I'm sending the application ID and I'm sending, okay, this data came from the staging environment. And I'm saying, okay, I want to log this particular data in the request logs. Uh, so here, once I run this, I'll get this particular trace and I can see some metadata icon over here, which means that this has a user supplied metadata to it. And these metadata tags are directly surfaced at the very top. Now I can use these metadata tags for all the features that I'll talk about further down the line in this call. So filtering, data access, data routing, things like that. Uh, and yeah, and the other toggle is XTFI logging config where I can say, okay, if this request should be logged or not. There will be a global config that I'll talk about, but you can control it based on header as well. Yeah, and yeah, like I was saying, you can then after these traces are logged and available, you can apply any lot of complex filters, like right, like based on whatever are the top level attributes as well as your own custom attributes that if you have added. Yeah, so I'll go over to the overview section over here, and we'll just walk through one of the traces. So as I was saying, this agent trace call, right, where I had asked for, okay, what is the total number of seconds till next solar eclipse? And here I have connected a bunch of MCP tools. Uh, and here I have, okay, I want to store this particular transaction or this particular chat as a trace in the gateway when I run it. So this particular thing has already run. So I'll just walk through the trace of this. So here I have the top level span, which is the agent response span. And here is a list of messages that I had sent. And here's the final response I got. So this is a overview. And if you go to the raw data section, you'll see these attributes are stored inside these special attributes, which are prefixed by TFI dot something. So we have a docs page covering off all these attributes, but all of the pretty view is rendered from this raw data. And further down the line, if you want, you can like query these spans and do your own analysis on top of this if needed. So this is the agent response span, and then we can look at, let's say, one chat completion span. Now this each chat completion span will also show you all the intermediate steps that happened in this agent response span. So we see in the first one, the model asked us to call the web search tool. Then the MCP web search tool happened where we send this particular thing as input to the tool called method of MCP, and we got back this as a response. This is a raw response. Then we send this raw response out to the model, and it basically decided based on that the output of this particular tool. It wrote some Python code. Then we called the code executor and so on and so forth. The entire call completed when we finally had the last chat completion call, where we got back the answer, and then this answer basically shows up as the final answer for our agent responses trace. Okay. Yeah, so that was one example of one trace. Now, based on the different configurations that you can do for each request, like the gateway supports routing config, it supports guardrails, it supports a bunch of global rules as well, right? So all of those things can be recorded and annotated. Like we see in this screen, we can see there was some load balancing rule applied over here. So in this case, a virtual model feature was used, so there was load balancing applied, and then here we also get to see, okay, which model got picked. So this particular model, it went first to this Claude 3.5 Sonnet, and it got a 404 there. So because it's a virtual model and there's a fallback configured, it then went to the Bedrock Claude Sonnet. Similarly, there are like if there are some guardrails being applied, then you will also get to see, okay, which guardrail got applied and did the guardrail pass or not. Yeah. All right. Uh, yeah, and then yeah, like I was saying, you can do all of this filtering. Like in this case, I'm already filtering out all the 404 calls, but I can say something like, okay, I'm interested in calls that took maybe more than 5 seconds. Yeah, and yeah, you can chain more and more filters where you can say, okay, show me only data that came from maybe only staging, right? Or in this case, I don't have something from staging, but yeah, so you can keep on chaining filters over here. All right. Uh, okay. Rishiraj, do you want to take a pause and see if there are any questions?
Yes, we can. Yes, folks, do you have any questions still up till here which you would like to ask? Uh, you can simply raise your hand and I'll unmute you. Yes, hi. Hi, Chandrasekhar.
This is Chandra. One quick question, right?
Sure.
So you are showing this traces in gateway portal control plane.
Yes. Yes.
Okay, what is the source of truth for this metrics? Where are you getting it?
Oh, okay. So basically, these traces are automatically generated when you, let's say, fire any query to the gateway, right? Either via the playground or either via the API. So the gateway, let's say in this case, I fired this chat completions call, right? The gateway will emit open telemetry spans that, okay, a chat completion request came in and the model call happened, a post call happened to OpenAI, and then we got back some response. So all of those traces are automatically emitted by the gateway inside the control plane, and then those you can access via the monitor section in request traces section.
Yeah, so that's right. So are you storing this data somewhere in the database, or are you getting this data for tracing purpose from Prometheus?
Oh, no. Oh, yeah, yeah, okay. So we are storing all of this data in the object store that you choose as a customer. I'll talk about that feature in detail. We have it coming up in the slides. So those are
Okay,
stored in object stores. The object store acts as a DB for this system.
okay, so you are storing it, right?
Yeah.
So how about any sensitive data, either PCI or PII
Hmm.
or
Hmm.
PHI data in the queries? How are we ensuring it is encrypted or masked?
So there are two different approaches for it. One,
Mm,
one is obviously you can bring your own buckets where you can decide where exactly where the data should go, and there on the object store you can configure your own encryption, own set of policies. And the other is you can always connect guardrails, which can mutate the data, right? Which can mask all of the PII if needed, and then that data goes to the model and gets recorded on the object store.
mm. So how can I access this object storage, object data storage?
We'll talk
So,
about this in the call.
okay, sounds good. Thank you.
All right. Okay. Okay. Let's move ahead. Uh, Folks, please keep on asking questions in chat. We There are people who will answer them async as well. Okay. Yeah. So all of the UI that I showed you, all of the data on the UI is also accessible via APIs, so that you can build your own workflows on top of it and build your own set of processes, right? So we have both a curl API and a convenient SDK to do this. And for this, you'll see there's a fetch via API button or right on the traces. There we will give you almost the exact code that is required to query all the spans that you see on the screen. And there, yeah, there's a whole docs page also written for to show you what all filters are possible with these APIs. So you can query all of this data and you can start using it in your maybe data science workflows or maybe for some other processes, right? Uh, I'll also talk about how this data can be exported to external systems. So like for one example is you might already be using some open telemetry compliant system, right? Like for example, there is Grafana Tempo, there is Datadog, there is New Relic. There are a lot of observability systems which are already open telemetry compliant. And maybe you want to export the data to those systems as well, right? So we have a feature called OTEL export config, where you can configure exactly what is your traces endpoint, what data should be sent, and you can even add your own extra attributes before it is exported to that particular system. So I'll and you can also configure if you want to include the input and output sent to the model, right? Like for example, there might be compliance requirements where you want to record all the metadata for the trace, but you don't want to export what prompt was sent or what response was received from the model. So we give that particular toggle where you can select if you want to exclude that particular attributes. And you can also additionally, before exporting, you can say only export the data which matches all of these attributes. Like one example is maybe I only want to export data which comes from which includes the model maybe GPT-4o or maybe some particular maybe data that was created by a particular some particular user. So you can add filters which need to match for the data to be exported. So I'll show one particular demo with how traces from TrueFoundry can be exported to New Relic. So if I go to, let's say, something like New Relic, in the settings, I will be in the integration and agent section. I will be able to create a open telemetry key. So if you search for open telemetry over here, you can create like a ingestion key over here. You can copy that key and then you can come to the let me just cancel this to the control section and inside settings, you'll find open telemetry config. Here I have put the New Relic's traces ingestion endpoint. I'm using the HTTP mode. Some OTEL systems also support gRPC, so even that is available. Uh, HTTP, you can select if you want to send traces in Proto or JSON. Again, this will depend on your receiver side, if that supports these protocols or not. I provided my New Relic API key. And then I can, additionally, if I want, I can say, okay, for all the traces that you're exporting, also add this particular extra attributes to it. Maybe this can be useful for your end system where you want to do custom filtering based on your own metadata, right? You can also select, like I said, you can select to exclude the request data, or and you can also put filters where you only want to export certain XYZ data based on the span attributes. So once I set this up and I get this going, my data in essence will start mirroring on, in this case, New Relic. So if I go to traces section, you'll see I have this particular traces which mirror the data that I was showing earlier. So in this case, let's say if I pick this chat completion thing, again here I will get that same trace view, but in a different in New Relic's UI style, right? So this just helps you keep your existing tools and also use them alongside the AI gateway monitoring section. Okay. Yeah, and then we have like we have already documented the process for a bunch of popular tools like Elastic, New Relic, LangFuse, Langsmith, right? So all of these traces can be exported to these systems. Okay. Uh, let's see. Let's go ahead. Okay, yeah, this is mainly the integrations. Okay, now I would like to talk about the recent changes in the Gateway Traces product. So, on an highlight basis, we have removed the concept of tracing projects. Earlier, I think some of you might remember we had a concept of tracing project which you had to create to configure your own bucket and route the data accordingly. We have removed that concept and simplified it on a central basis where data access is now completely decoupled from how you write data. So data routing is another feature which allows you to control where the data should go, and data access allows you to control who should have access to what data, right? So let's talk about this in little bit detail. So earlier there used to be a tracing project concept where there was a TFI default tracing project which allowed everyone access to their own data. And then if you had to route data to your own bucket, or if you had to do custom access control, you have to create a tracing project, and then you have to, while making the request, you have to pass the tracing project ID. Then you have to make sure everything was set up ahead of time. The reason to remove it was primarily the that we didn't want our end applications to have that overhead, right? Like some particular manager or admin had to create these tracing projects ahead of time. They might or might not know the complete use case ahead of time to create these tracing projects. Then they had to provision different API keys for each tracing project. Then they had to instruct the application owners to send that particular tracing project ID in the headers. If there was some mistake, then you had to roll out your own application again. And then they just created a lot more overhead before you start before you were able to start using this feature. And then there was also no flexibility to bring your own bucket as the default storage for everything. You had to create a tracing project to just to be able to use your own bucket. So we have removed this tracing project feature and kind of broken it down into two different things, where the read part and the write part are completely decoupled now. So in the control section, you will find two new sections. One is called data access and one is called data routing. Data access simply defines like who has access to what data based on a certain attributes of the data itself, right? So we seed three rules by default. Like in this case, everyone has access to their own team's data. Everyone has access to their own data, which is kind of implied. And then the tenant admin has access to everything. None of these rules are compulsory to keep. You can disable these rules, and those rules will no longer be considered while giving like returning the data back to the user. And then you can also define your own custom rules with custom like attributes. I'll show a demo of this now, which will make things a lot more clear. So if I go to controls data access, here I can add new rules. So let's say if I want to add one custom rule, I can say maybe, okay, something like custom rule, and I can put some description. Now I can select who do I want to give access to, right? Like in this case, let's say maybe I can say I want to give access to Akash and maybe the backend team. And I can say what data I want to give access to. They should have access to, maybe only they should only have access to the metrics. Maybe they should not have access to all the traces. And which metrics, right? Like the metrics created by themselves, team data, or maybe all data, but filtered by certain conditions. Like maybe something like I only want to give access to data which is coming from this particular health application, or maybe I only want to give data which was created by maybe by me, right? Like so, oh, maybe my user does not exist. Like let's pick another user, right? So maybe by these users and this particular virtual account. Okay. So these rules get saved, and then when anyone is accessing the data, we will evaluate all of these rules and we'll take a union of these rules. Based on the rules, whatever data you have access to, that data will be now be visible under the monitor section for you. So here there is no concept of like the downstream application does not have to do any sort of management where you have to pass some tracing project, or you have to configure like which user should have access to which tracing project ahead of time. You just define the rules based on the data and the roles, and all of those get applied at once. I'll take a pause over here just to see if there are any questions around this part. Rishiraj, let me know if there are questions which I should
Yes,
answer.
folks, if you have any questions, you can like raise your hand, or else we can take all the questions like right after this, whichever makes sense. If there are no questions, we can like simply continue.
Hmm.
Yeah, there are no questions.
Okay, okay. Okay, this was on the reading side of things, right? Like who gets access to read what data. Now let's talk about writing side of things. So in essence, there is there's no role-based control on who gets to write data. As long as they're authorized to use the AI gateway, their data will be recorded based on the rules which are configured by the tenant. But there's no special restriction that this particular user is not allowed to data, or this particular user can only write to some XYZ location. Uh, the data the data will be written, but where it gets written can be controlled by the tenant. So that next feature is the data routing part. Here you can define very similar to data access, where you were defining a bunch of filters based on metadata or created at. Here you can define based on those same attributes where the data should go, right? So we can imagine one particular example, right? Like which was brought earlier in the call, where there can be some sensitive medical app data which needs to follow very strict compliance, where it needs to go to a certain particular bucket which has its own custom policies, and it needs to reside in some particular location which is already decided by the bucket. Maybe that data needs to be only in the US and not go outside. So all of that decisions can be encapsulated in this data routing feature, and it can be applied on the fly when the data is being generated. So if you look at the basic data routing feature, we now support bringing two different kind of storages. One is a control plane managed storage, which is already connected to your control plane. So when you're setting up the control plane, there's a bucket that you have to attach to it. If you're using the SaaS version of our product, these buckets are managed by TrueFoundry, and we provide these buckets in multiple regions like Ireland, US, Australia, India. Uh, and you also, on the other side, you also have the option to bring your own buckets, so customer managed buckets. So if you go to the platform and connect your buckets, you can choose those bucket over here, and then from that point onwards, the data should start flowing to your bucket. Uh, I'll show a detailed demo of this form as well, which will make things a little bit more clear. So if you go to controls and data routing, you'll find this particular section. We have two different sections over here. One is a default destination, and one is a set of rules that you can define which override the default destination. So default will always be used if for metrics. So all metrics will always go to the default location. But if you're talking about traces, right? Traces has all of the sensitive data, right? Where there can be prompt response, or there can be custom PII data. You can define a bunch of rules which need to match to go to some particular storage location. So if you look at this particular rule, this is a rule name, and I'm saying if the trace has a metadata, which is the key should be app and the value should be health, then it should go to this particular GCP bucket that I've connected to the platform. And then this rule is enabled. And similarly, I can keep on adding more and more custom rules. So what will happen is, let me show a more detailed example where we have more rules. Let's go here. Uh, Let me see. Hopefully this loads fine. Okay. Maybe. Oh, okay. It loaded. Okay. So I can keep on defining rules, and I can have them enabled or disabled. And the rules basically will be evaluated from top to bottom. These rules have an ordering where you can reorder these rules as well. Uh, and whatever rule first matches, the data will be routed to that particular bucket. So in this case, I'm saying, okay, if the data was created by this particular user or this team, and the metadata also had these values, then it should go to this bucket. Otherwise, keep evaluating the rule till something matches. And if nothing matches, then you can go to the default location. Let's now try adding a rule. Okay, so I can give some, let's say, example where I say custom rule, this is enabled. Then I can define some particular rule based on, let's say, metadata, or I can define by who created this particular data. Maybe in this case, you are using a unique virtual token for your application, right? So if the data was created by that token, it should go to, now I can decide where the data should go. Either it can be control plane managed storage, which in which case I don't have to make any further decision, or it can be control plane managed storage where I select the blob storage that I've already configured in the platform section, and then I can decide how long should the traces data live in that particular bucket. If you don't set anything, that's infinite retention, and I can submit this. This rule is now added as the second rule to evaluate. If needed, I can reorder these, and I can just save. So now let's say if I take this, right, like in this case, let me just edit this rule quickly to show this working. I will remove this particular condition for now. I can just say app ABCD, right? So I can go to my playground section, and in here I can add app ABCD. And then now whatever request I send will be sent to the bucket, the Azure bucket that I had selected for this particular rule. In here, like the same flow is obviously also possible via the code where you can send this XTFI metadata that we talked about earlier. Uh, Once this happens, I can go to the monitor section in the request traces. Now the same destinations are also visible over here. So you'll see I can basically select any one particular destination, and that particular data, like this came from app health, so this went to health app logs. And similarly for whatever custom rules, uh, okay, maybe it will take a little bit while for this data to show up over here. Let's see. Okay, we'll come back to this, but yeah, so now there's no concept of passing any tracing project ID or header in the request, right? The all of this configuration can be centrally controlled, which reduces the chances of mistake, right? The application does not get to say where the data should live. It's all centrally controlled and managed by the tenant admins. Okay, I'll take a pause and see if there are any questions which should be answered based on this. No? Okay, I'll move forward. Yeah, so you should keep in mind, like changing a storage location for a particular rule is allowed, but that comes with a few implications, where your existing data on on the object store will not be deleted, but it will become inaccessible via the APIs because you're essentially saying that the destination now points to a different bucket. And your existing data from that particular bucket will also not be automatically migrated to the new location. So if you're changing this, know these things ahead of time, and most likely these things do not need changing all the time. You change it maybe once when you set it up, and you can always keep on adding new rules, right? So you can disable the older rules and you can add new rules. So like in essence, there should not be a lot of need to change the destinations, but it's an option if that's required. Yeah, this is another use case. For example, you might want separate buckets for dev and prod. So if you add some metadata like environment dev, environment prod, based on that metadata, you can set up the data routing rules in a way where data goes to different buckets. Uh, yeah, and also note this feature is only available in the enterprise plan at this moment. So if you're interested in this feature, reach out to the customer success team. Okay, that's the whole part of getting rid of the tracing projects thing, where things become much simpler by just configuring where to write and who gets access to data. Uh, there's also one central config which allows you to control how data should be logged, right? Like, should it be always logged? Like in the sense, metrics will always be recorded, but do you always want to record the prompt and responses? For some customers, it's important that it always gets recorded. Doesn't matter, the application doesn't have any say in this. For some applications, for some customers, it's also a use case where they never want to log any of the prompt and responses part, because that can contain highly sensitive data and they don't want the gateway system to have it. Or they can allow the application to choose based on the header. So the XTFI logging config that we saw earlier, if that is enabled true or false, then the application can decide based on certain request if that should be logged in the traces section or not at all. So earlier this config used to be in a environment variable, and you had to host your own control plane for it. But now it's available as a tenant level setting, so you can configure it for your own. All right. Sure. Okay, let's go ahead to. Okay, so there's also a feature which we just launched last month. So now we support adding feedback to traces. What that means is you can. I think many applications have a use case like they want their users to put maybe thumbs up, thumbs down, or maybe they have an internal set of annotators that can look at a trace and decide, okay, the model messed up over here or the model did good over here. So maybe you want to rate those particular interactions, right? So we have a general concept that you can put feedback on any particular interaction on the gateway. Uh, and it sort of looks like this, where you can see I've put a feedback on this particular trace. I gave it 4 stars and I said, okay, the model did well, but it missed one case. Like I put some particular string comment over there. Uh, and I'll walk through how you can use this particular feature. Right now, this whole feedback feature is driven by APIs. Like there's no button over here to directly put feedback. That can come later. But yeah, let's walk through how you can put feedback over in this, right? So here I have a sample code where I'm sending request to our gateway. And I just sent like one dummy request where, okay, like what are the compounds in this cough syrup? And and all of this stuff is optional, like you don't necessarily need to send it. Once I complete this particular request, in this case, I did it with raw response because I want to access the response headers from this particular request. Uh, After this request completes, in the response headers, you'll get this particular special header called XTFI feedback target ID. This is an opaque target ID. You don't need to worry about the value of this. What you can do with this particular value is you can call an API called V1 gateway feedback. We have docs for this again. You can pass this feedback ID over here, and then you can pass, okay, what is the rating between 1 and 5? What is the comment if I want to add something, and any additional attributes, right? Like maybe make sense. Maybe you ran some sentiment classifier on top of it and you want to record that, or maybe any other evaluation attributes if you want to add. And you post this, the feedback will be then connected to the trace. It will be recorded in the same object store and connected to the trace. And you get back an feedback ID based on which you can update the feedback or delete the feedback if needed. So we have APIs for all of these, creating, updating, and deleting, and then obviously listing the feedback itself. Uh, yeah, so that feedback roughly looks like this. On the root span, you'll see like a star, and you'll see a special tab called feedbacks, which lists down all the feedbacks that have been given to this trace. There can be multiple. You can, with the same feedback target ID, you can keep on sending multiple, and all of these will get recorded. And then, yeah, if you want to look at all the data that has feedbacks, there's a special filter called feedbacks, which has present true or false. So, yeah, so we build this feature to allow you to record maybe end user feedback or your internal annotation feedback. And you can imagine you can do some things like maybe this helps you to curate your data set for maybe training some internal model or building some flow based on the user feedback. Yeah, okay. So I can talk about the last thing. Let's see. Okay. So earlier we talked about this whole system works on top of object store, right? Like this diagram roughly sort of depicts how the data reaches your object store. There's like the gateway which emits OTEL, open telemetry compliant traces, that goes to our OTEL collector which runs inside the control plane. And then to that it goes to our ingester pods which are again in the control plane, and then the data is then put to your either to your bucket or the control plane managed storage that you have selected. Now, because of this nice thing about data living inside your bucket, right? And the format of the data that you have selected, it's an open standard. We store the data in Delta Lake format, and those files inside the data are in Parquet format. So the very nice thing about this Parquet data is, if you're interested in this particular low level kind of analysis, and if you have access to this bucket where the data is going, you can pull down these Parquet files in your any code that has libraries that can work with Parquet. Like for example, in Python, Pandas is a very popular library which works with Parquet files. You can pull down those files and you can do any of your custom analysis if you want. So for example, I have this Delta Lake and Pandas library installed over here. I have this particular bucket. Inside the bucket, you'll have a path where your data is stored. So if I just do, in this case, I was using S3, but again, any object store that you bring in is supported. So I did S3 ls over here and I selected a path inside this traces table. The data is partitioned in by date and hour. So I see it's just a bunch of Parquet files. And the nice thing about that is I can load this particular delta table if I have access to the bucket. I can list down what all files are part of this particular delta table. And I can just simply use pandas, right, to read this particular file. And you can see there are all the columns available that we store inside your object store. Uh, Now, normally we will not recommend this flow. We will recommend that you use the fetch API to get all the traces, because this particular data is a little bit in the raw format, right? Like where all these span attributes are stored in different columns, and like it's this particular schema is ideal for storing but not ideal for direct consumption. So whenever possible, if possible, you should always try to use the uh, query spans API first. But in case you want that particular flexibility, we don't try to vendor lock you in anywhere. You can always access those files and directly start using them in your data science workflows. Okay. Yeah, that's all I had to cover. Yeah, we